Bismillahirrahmanirrahim. Hello everyone. I hope you are all doing well. I welcome you all to the class of real analysis. In today's lecture, we are going to discuss an important proposition that is related to field. The proposition in your textbook, Principle of Mathematical Analysis by Walter Rudin, is labeled by number 1.18. So this is the proposition 1.18 that is actually related to the field. Uh, in this proposition, we have to prove some axioms that is satisfied by any field with two binary operation plus and multiplication. So the proposition says that if f is a field, then for any xyz belong to f, the following axioms hold. The first axiom is if x is greater than 0, that is x is positive, then we have to show that minus x is less than 0 and vice versa. Vice versa mean when minus x is less than 0, then x will greater than 0. In the second axioms, if x is greater than 0, that is x is positive here and y is less than z, this is given. We have to show that xy is less than xz, that is by multiply the inequality. After multiply the inequality y less than z with the positive real number, we need to show xy is less than xz. Similarly, the third axiom is if x is less than 0, that is x is negative and y is less than z, then we have to show that xy is greater than xz. Fourth one, if x is non-zero real number, then its square x square will greater than 0 always. And in particularly, 1 is greater than 0. Fifth one, if 0 is less than x and x is less than y, mean to say x and y both are positive real number such that x is smaller and y is larger real number. We have to show that 1 over x, that is the reciprocal of x, is greater than the reciprocal of y, but both reciprocal are greater than 0. So these are the 5 axioms that we need to show. First axiom, it is given that x is greater than 0, so we have to show minus x is less than 0 by adding additive inverse of x. What is the additive inverse of x? Minus x. Minus x, by adding minus x on both sides of the inequality. So when we multiply, when we add minus x on both sides of the inequality, the sign of inequality will not change. Due to the result, we say when x is greater than y, then x plus z is always greater than y plus z, where z is a real number. So this will become minus x and plus x. These are the additive inverse of each other. So this sum will equal to 0, and 0 is here additive identity. So by adding 0 with the real number minus x, this will become minus x. So minus x plus 0 is minus x simply, and minus x plus x, this is equal to 0. So we have 0 is greater than minus x, or in other words we can say that minus x is less than 0. So this is our first result, first requirement. Now we show that when x minus x is less than 0, then we have to show x is greater than 0. Mean to say when we multiply, okay, now consider minus x is less than 0, again by adding the additive inverse of minus x. What is the additive inverse of minus x? This is plus x. By adding minus plus x on both sides, this will become minus x plus x less than 0 plus x. Minus x plus x, because these are the additive inverse of each other, so this is simply equal to 0, and 0 is the additive identity. So by adding this with real number, this is equal to x simply. So 0 is less than x, or we can say that x is greater than 0. So this completes the proof of axiom 1. Now we move towards the second axiom. The second axiom says that when if x is greater than 0 and y is less than z, we need to show that xy is less than xz. This property actually says if we multiply an inequality with positive real number, then that positive real number will not change the sign of inequality. Because x is positive here, and when we multiply x on both sides, this will become xy less than xz. How we will prove this? It is given that y is less than z. So by adding the additive inverse of y on both sides, by adding additive inverse of y, what is the additive inverse of y? This is minus y. By adding minus y on both sides of the inequality, this will become minus y plus y and less than minus y plus z. Because this is the additive inverse of each other, so this sum is equal to 0 simply, and this can be written as z minus y. This shows that z minus y, 0 is less than z minus y, can be written as z minus y is greater than 0. Now multiply x on both sides, we have x into z minus y greater than, because when we multiply 0 with x, this is equal to 0. 0 into x is equal to 0. Now here by using the distributive law of multiplication over subtraction, we have x into z minus x into y, like this. X into z minus x into y greater than 0. By adding the additive inverse of minus x, that is actually plus x y on both sides, we have, in the above inequality, we have xz minus xy plus xy greater than 0 plus xy. This is the additive inverse of each other. So this will become equal to 0. This is equal to xz greater than 0 is the additive identity. So by adding 0 with xy, this is equal to simply xy. So xz is greater than xy. Next in the third property, that is similar to the second property. Here x is a negative real number and y is less than z. We need to show that when we multiply this inequality with a negative real number, this will reverse the sign of the inequality, that is less than sign will change to greater than sign. So our target is to show that xy is greater than xz. So consider the inequality y less than z. So consider the inequality y less than z, and similarly as above property, we add additive inverse of y on both sides. This will become minus y plus y less than minus y plus z. Minus y plus y, this is equal to 0, and it can be written as z minus y. That is 0 less than z minus y, or can be written as z minus y is greater than 0. Now multiply this inequality on both sides with x. Because now x is a negative real number, so greater than sign will change to less than sign. And on the left side, we use the distributive law of multiplication over subtraction. It can be written as xz minus xy, 0 into x, this is equal to 0. Next, by adding the additive inverse of minus xy on both sides, we have xz minus xy plus xy less than 0 plus xy. Minus xy plus xy, these are the additive inverse of each other, so this is equal to 0, and 0 plus xy, this is equal to xy. Hence xz is less than xy. Fourth one, this is an important property. We have to show that if x is any non-zero real number, we need to show that its square is greater than 0. For every non-zero real number, like as our real number is 5, then what is the square of 5? Square of 5 is 25. Similarly, if our real number is minus 5, then again its square will be 25. So in both cases, either your x is negative or positive, but it is not equal to 0. Either your x is a negative real number or positive real number, its square will always greater than 0. This is our target to show. So in particularly, we have to show that 1 is also greater than 0. So here we will consider the two cases. It is given that x is non-zero. When x is non-zero, it means either x is greater than 0 or x is less than 0. So consider the first case, when x is greater than 0. Because x is greater than 0, so multiply this x with x itself. Sign of inequality will not change here. This is equal to x into x, and this is equal to 0 into x. X into x, this is x square. 0 into x, this is equal to 0. This shows that when x is greater than 0, then x square is greater than 0. Similarly, in the second case, when x is less than 0, when we multiply this x, this inequality with x, because x is negative now, so the sign of inequality will change. Less than sign will change to greater than sign, and x into x, this is equal to x square, 0 into x, this is equal to greater than 0. So in both cases, when x is non-zero real number, then x square is greater than 0. Next we have to show that 1 is greater than 0, because 1 is not equal to 0. 1 is not equal to 0, so its square will greater than 0. We have shown that if x is any non-zero real number, if x is any non-zero real number, then its square is greater than 0. Now if our x is 1, and 1 is a non-zero real number, so according to this result, its square will be greater than 0. So our x is 1, so its square will be greater than 0. So 1 square is greater than 0 mean, what is the square of 1? Square of 1 is 1, so 1 is greater than 0. Last one. In the last property, we have to show that if x and y are the two positive real numbers such that x is smaller real number and y is larger real number, then we need to show that the reciprocal of x is greater than the reciprocal of y. That is 1 over x is greater than 1 over y. So here, firstly we consider it is given x is greater than 0. Where it is given? In the property says x and y both are positive real number. It means x is greater than 0. So here it is given that x is greater than 0. Firstly we show that 1 over x is greater than 0. When x is greater than 0, firstly we show that its reciprocal 1 over x is also greater than 0. We suppose on the contrary that 1 over x is not greater than 0. It means when 1 over x is not greater than 0, it means 1 over x is less than or equal to 0. Suppose on the contrary, 1 over x is less than or equal to 0. Multiply on both sides with x. Now, because x is here positive real number, so when we multiply x on both sides, sign of inequality will not change, and this will become x into 1 by x less than or equal to x into 0. Because x and 1 over x both are the reciprocal of each other, multiplicative reciprocals. So multiplicative inverse. So this side will become equal to 1, and x into 0, this is equal to 0. So we have 1 less than or equal to 0. This is not possible. 1 is always greater than 0. We have proved in the above property that 1 is greater than 0. So 1 is greater than 0. This is impossible. Thus, it means our supposition is wrong. What was our supposition? Our supposition was 1 over x is less than or equal to 0. This supposition is wrong. Hence, 1 over x is greater than 0. Similarly, here we can show that because since y is greater than 0, hence its reciprocal 1 over y is also greater than 0. So if here 1 over x and 1 over y both are the positive real number, we know that the product of two positive real number is always positive. So 1 over x and 1 over y, their product will be greater than 0. This implies 1 over x, y greater than 0. Now we consider the second part of the inequality. The second part of the inequality is x less than y. Now consider this part. Multiply on both sides of the inequality with the positive real number 1 over xy. We have shown here, 1 over xy is greater than 0, mean to say 1 over xy is a positive real number. So multiply on both sides of the inequality with 1 over xy. So the sign of inequality will not reverse here. 1 over xy into x less than 1 over xy into y. 1 over x and x both are the multiplicative inverse of each other. So this will become 1 over y, and similarly here 1 over y and y both are the multiplicative inverse. So this is equal to 1 over x. This shows that 1 over y and 1 over y is less than 1 over x. Further, 1 over y and 1 over x both are the positive real number. So finally they can be written as 1 over x is greater than 1 over y and 1 over y is greater than 0. So these are the 5 axioms that is related to the field. I hope today lecture is very helpful for you, and you have now clear understanding about today lecture. Inshallah, in the next lecture we will discuss about uh, properties of supremum and infimums. So see you in the next lecture. Take care. Allah Hafiz.